welcome to the tutorial, the next installment of the tutorial on Python for data analysis. Today, we will be looking at functions and classes. So, what we are really going to be doing is trying to create objects that allow us to repeat several operations. So, if we have to do something a number of times, instead of writing all the code required to do that thing every time, we can package that code into either a function or a class, some form of object, and then reuse these objects. So we will begin with functions. Functions are very simple. Functions. Uh, a function is a very simple thing. To define a function, you start with the def keyword. So def, and then we write the name of our function. So here I'm going to call it greet, and then your parentheses, the colon. And then inside here in this indentation, you can type in whatever you want your function to do. So here I'm going to just print hello world. And that's a function. And if I type in greet, if I call the function, it prints out hello world. So this is really basically the simplest definition of a function. Um, y- you don't, in this one, you don't really have to return anything. But here I'm going to make a more useful function. So here, more likely you will see and you will use and create functions with parameters. So if I have to do a computation over and over and over again, I can define a function that does that computation. So I can say def some, I'll just call it some calculations, and I'm going to return the results of my calculations. So you can do this with anything. Let's say you have two numbers, A and B, and we want to, with our calculations, let's say add the, let's add A to B. We want to subtract A from B. We want to multiply A and B, and we want to divide A by B. So I will write here the sum equals A plus B. Here, the difference is subtract A from B, B minus A. Going to call this the product, A times B, and this division result, A divided by B. And then I'm going to return, I can return all these, um, okay, sum is a keyword. Over here, I will call it my sum, my sum. And I can return all these. So I can return my sum. I can return the difference. I can return the product. And I can return the result of that division. So if I call the function, call it some calculations, let's call it 3 and 6. So it returns the sum. 6 plus 3 is 9. 6 minus 3 is 3. 6 times 3 is 18. 3 divided by 6 is a half. So, and I can do this for some calculations. I can do this for any two numbers. 4 and 8 will give me this. Some calculations. 13 and 98. Okay, so we can do this if we need to do a particular computation over and over and over again. Instead of typing all this every time I need to do these computations, I can just put this in a function. And of course, here, what you can really do if is, let's call this res1, res1, res2, res3, res4 equals some calculations. Some calculations, any two numbers, 20 and 60. And now you can use res1 as you like. You can use res2 as you like. So now you can use the output from this function. Um, further along in your code. So now the outputs, the number of variables that you're getting out of the function. So on this left hand side, they should equal the number you returned. So if I were to do this and remove that, I would get an error. You would see too many values to unpack. Expected 3 because I have 3 here, but I'm returning 4. So this will give an error. So when you return things and you want to use those things further down along the line, you just have to make sure um, that the number of outputs you're given from your function equals the number of variables you set here, and then you can use these in your future code, as you would like. Okay, so this is what functions are. They allow you to do the same calculation or the same sort of processing over and over again. So here we have seen a function with some parameters a and b that we allow the user to define. Um, we can also have default parameters. So if the user doesn't specify one of these, it will still run. So let's have a look at that. So functions with default parameters. So define my function def keyword. I'm going to power first parameter base, second is exponent, and to make it default, I will put the equals to. Return base to the power exponent. So this is my function. I'm going to do something to the power of something else. So for example here, power 5, 5. So 5 times 5 is 25 times 5, 125. So what that is doing is 5 to the power of 3. So 5 times 5 times 5. Um, I specified the base here and I specified the exponent. Because I have the exponent as a default parameter here, I can just do power 5 and it will give me 5 times 5. Sorry, 5 to the power, yeah, 5 times 5, 5 to the power 2, which where 2, so if you don't specify anything, it will use the default. If you do specify something, it will then use that thing. So you can have a function with default parameters. Okay. So these are what functions do essentially. Um, they are quite simple. A function just lets you repeat several operations with a single command. Uh, and we know how to return a value from a function. So here, if I had to do these computations um, over and over again, I can just write a function to do that, and I could call the function with different inputs and get my outputs out. I can return as many outputs as I want within reason. At some point, maybe it gets too untidy, and then maybe you have to think about creating a different type of custom data structure that you can return things out of. Maybe instead of returning 30 things or something, maybe create a list, add all those things to the list, and then return only that list, for example. But you can return multiple things from your functions. Okay, so that's functions as simple as can be. Um, I guess data science, um, some examples, you could write a function to, if you have to do the same type of processing on your data, you can write a function to do the same type of processing. If you were to, you know, train your model and you wanted to calculate the accuracy and print out the confusion matrix, you could write a function to evaluate your model and so on. So you can see if you're doing any sort of data science operations over and over again, instead of writing the same lines of code all the time, you can encapsulate that into a function and then just call the function. Okay, so now we're going to move on to classes. So classes are just like functions, except they're a little more involved. The same idea behind classes as behind functions. You want to be able to reuse objects, but classes are more powerful. You can extend. So, so here, the example with classes, we can let's start with assuming we want to create a class called book. So in this class, we're going to create this class called book, and then we're going to be able to create several different books based on this class alone. So we're going to reuse this code. So the first thing you see with a class is the constructor method. So whenever you create the new objects, this is what you will see. And again, it starts with def, two underscores, init, two underscores, and then self. Now, a book has at least two things: a title and an author. So my book class is every book I create is going to have a title and an author. Then I'm going to create the instance variables. So the class is the general object. And then when I create a specific type of book, that would be an instance of this class. So every instance will have a title, whatever title I specify, and an author. Okay, so this is um, the instance variables. Every time I create a new book, it will have a title and an author. And I can have other I can have other um, functions or methods in this class. So this is another instance method. Uh, I'm going to define a method to display the book properties essentially. So this display function is basically going to let me print the title and the author of the book. Self.title by self.author. So this is my class. I want to create the number of books. So I'm going to be reusing this object. So say book one equals, I'm going to call the book object here. And the book has a title and it has an author. So let's say the first title is 1984 and the author, George Orwell. So that's my first book. My second book, book two, will be again, um, let's see, The Hobbit, J.R.R. Tolkien. So these are the two books I've created based on this book class. And what can I do with this? What can I do with these books? Well, there is a method in here that I created. So book one dot display, and it tells me, hey, this is the title of the book, 1984 by George Orwell. And I can do the same for the second book. Book two dot display, open bracket, close bracket, The Hobbit by J.R.R. Tolkien. So this is a simple class. Um, you need some sort of constructor. Okay, what is the class going to be about? And then other methods that the class can use. So here is another example. Um, let's call this, let's have a bank account example. So, oh, sorry, begin with class keyword, call that bank account, and my constructor, underscore underscore init underscore self owner, and let's say the initial balance is 0. So again, you will recall from functions, this is a default parameter for balance. Okay, every bank account, let's say, starts with 0. Okay, I forgot the, you know what, I will put this later on. Okay. So every bank account has an owner, self.owner, and self.balance equals balance. So constructor with a default parameter, and the balance here default balance is 0. Okay, so now we have our class with the constructor. The bank account has an owner and it has a balance. So now we can add methods. So a useful method would be to add money. So method to add money to the account. So let's say DEF deposit some amount, and then when we deposit the amount, our balance will increase. So we have to update the balance whenever we deposit. So self.balance plus equals the amount. So the balance plus the amount we deposited, and we can print we say deposited, let's go EUR. So we deposited some euros. Our new balance is EUR self.balance. So the new balance that has been updated here. So that's one method. Obviously, another method um, would be to withdraw money. Method to withdraw money. So df withdraw self amount, and then when we withdraw, we have to update the balance. So self.balance minus equals amount, and we can print withdrew EUR some amount. New balance is EUR self.balance. And let's give a final balance, a final method, sorry, method to get current balance. So try to see if you can just write this very simple method to get the balance out, to print the balance. So have a go, pause the video for maybe 2-3 minutes, have a go at that, and see if you can get a simple function. Okay, so there may be other ways that you were successful at doing this, but one way is to at least one function. I'll just call it get balance self. So we don't need amount because we're not doing anything with the amount. We can just return the balance, or maybe you decided to print the balance. So this is our class. So let's use this account, this bank account class. So account one, I will say account one is the bank account class that needs an owner and the balance. So the owner, Alice, and her balance is 100 euros. So we're not going to use the default balance of 0. We're going to use 100. Okay, so that's the account. Of course, we can deposit into the account. Let's deposit 50 euros. Um, let's run this. Okay, so deposited 50. New balance is 150, and we can withdraw account one dot withdraw. How much are we withdrawing? 30 euros. And if we run this, we see, okay, she withdrew 30 euros. Her new balance is 120. Okay, and let's account one the deposit. Let's make a couple of deposits. Alice got a new job. She deposited 2,000 euros. Okay, that's her new balance. And somebody gave her a gift of a birthday gift, 500 euros. So now her balance has increased. And with all the new money that Alice is getting, she's not sure how much is in the account. So, she wants to check her balance. So get balance. So account one, the get balance 2,620. And this is just for one account. So we can do this again for a second account. Account 2. Um, Equals bank account, say Bob. But Bob has a silver spoon. I was born with a silver spoon in his mouth. So starts off with 10,000 and um, account 2 dot deposit. Bob has a nice job, so he's gonna be depositing 4,500. So again, he deposited 4,500. The new balance is 14,500, and so on. So just with this class, we can a class is a very useful thing. You can reuse over and over and over again. So before we look at, I think next, because this is Python for data analysis, let's see how this can be used for maybe a data analysis application. Okay. So the point of object-oriented programming is to be able to reuse objects. So if we were doing some data analysis, some machine learning, um, so for data analysis, let's see how we can use this concept of classes and functions. Basically creating reusable objects. Okay, so I want to do some training of a model. Okay, I'm going to say, I'm going to create a class, call it model trainer, because I want to be able to um, use this class over and over again. I need to train many models. Okay, so I will start with my constructor. Let's see, underscore underscore init underscore underscore self and a model. I'm going to be training some machine learning model. And I'm going to define the model I use. It could be a number of different models. Okay. Um, let's uh, let's say method. I'm going to define a method for training. I'm going to define a method for testing or evaluating my training, the results of my training procedure. Okay. So method for training, I will say def train self um, x train y train, and I'm going to fit the model to this training data, x train y train. So that's, I'm going to be able to use a bunch of models that I specify, and I'm going to fit the model to this training data. And then I'm going to be able to evaluate the results of my training. So self, I'm gonna say X test, Y test, self. Actually, we predict first of all. So predict, prediction equals self dot model dot predict X test. And I'm going to get my accuracy out. So I need to import if from sklearn, from sklearn dot metrics import accuracy score. Accuracy score. So I can calculate the accuracy. Okay. So after predicting, I will test how accurate my prediction is. So accuracy equals accuracy score y test prediction. So test my prediction against the actual values, and I can print accuracy accuracy is and then return accuracy. So this is how um, you could use classes and functions, the object-oriented approach for data analysis. Okay, I want to be able to, instead of having to type this all the time, what I can do is, let's say I want to try a random forest, um, random forest model from sklearn to ensemble import random forest classifier. So I will say trainer equals my model trainer, and I'm going to put this model in there, random forest classifier. I don't need this bracket at the top. That's a mistake. Okay, so this is trainer. Maybe call it trainer one. Trainer one, the train. So it's going to call this train, and it will fit this model. It will fit this random forest classifier on my X train, Y train. X train, let's see, Y train. And I will be able to evaluate trainer one dot evaluate on X test, Y test. Okay, so here is like how I can use this. So let me actually try to run this by getting some real data in here. So we're going to use the iris data sets from sklearn dot datasets import load iris. Okay, so we're going to use the iris data set, and we are going to model selection. We are going to need to split this into into our training and test sets. So train test split. Okay, import. Okay, so train test split. Um, I have here iris, load iris. Um, let's just have a wee look at that. Okay. Um, okay. Um, so we say X is the iris dot. The X is the data. Y would be our target. Iris dot target. Okay. So now we can do our split. Let's say X train, X test, Y train, Y test equals train test split. And we're going to feed in our X, feed in our Y. Say test size equals 0.3. So 70% in the training set, 30% in the test set. Okay, so let me run that. And I'll just have a go. Just look at what's in this X train. Okay, we've got some stuff in there. X test. Okay, the features. Y train, same for Y train. And we have the labels for the training set and for the test set. Okay, so let's see if this works. So it works. In For this random forest classifier, our accuracy is 0.93 or 93%. And what did it do? It took in a model, it trained the model, so it fit the model, and then it evaluated the model. I can say trainer 2. Actually, I should import another model I want to easily compare. sklearn dot ensemble. Okay. Import gradient boosting classifier. Okay, there is some randomness going on. We didn't set the seed, so it changed. But model trainer, gradient boosting classifier, I say trainer 2, the train, feed in X train, feed in Y train. trainer 2 that evaluate feeding X test and Y test. And if I run this, um, I get my own accuracy. So I could have set a random seed to make sure I get the same answer every time I maybe run this classifier, but I didn't. Um, but this is what you can do. Instead of having to type in all this every time, train, test, evaluate, all this code, we just create our class model trainer, and we can we can just use this object every time we want to test a new classifier. And of course, we can extend this. So here, um, we could have done some pre-processing. We could modify this to do maybe modify this to take in the data and do some pre-processing, uh, maybe standard scalar. So you don't have to do this all the time. You can just create a class. It does all this for you, and then you just simply call this object, um, and then get your output, whatever output you want. So this is it for functions and classes. Um, we have just started with classes. There will be a second and final tutorial on classes where we will go deeper into more of the attributes. Okay, so we will look at private attributes, inheritance, polymorphism, special methods, static methods, class methods, and so on. So we will have one final tutorial session on classes. But what we've done today is define a function so that we can repeat several operations. And we've seen how to return a value from a function. We've also seen how to define functions, with default parameters. So define a function, the def keyword, the name of the function, and then open bracket, close bracket, colon. And then whatever you want in the function, typically there will be some sort of return statement, return keyword. If you call the function, you just type in the name of the function along with the open bracket, close bracket. This function has parameters, so it takes in two parameters, A and B. It does some things to them, and then it returns the output. So I can call this function with any value of these two parameters I like. So 3 and 6, it gives me the outputs. 4 and 8, it gives me the outputs. 1398, it gives me the outputs. And then because I return these four objects, I can capture them here with these four variables. So I can capture them here. And then further along the line in my code, I can use them as I like. So this is the basic definition of functions, a very useful concept. So here we saw where we input our parameters, but sometimes maybe you want to have a default parameter in there, that sets in there, and occasionally maybe the user wants to use their own parameters. So for example, here, 5 to the power 3, because I specified this 3, it will use the power 3. If I didn't specify anything, it will use the default value 2 over here. And of course, with data science, with you can create your own functions. So if you wanted to, every time you wanted to start a project, you would, maybe you read in your data, or you get your data, maybe check for missing values, print summary statistics. You can define a function that just does that for you, and you'll probably see more of this in one of the modules you do on engineering and evaluating AI systems. But functions just allow you to do the same operation over and over again without having to the repeat a bunch of code. So this is an object that you've just created. And of course, um, with classes, you can create even more powerful objects. So here, this is a class book that will let us create multiple instances of this object. So for example, this book class, to begin with, we have the constructor. Okay, what does every book have? It has a title, it has an author, and I'm going to instantiate um, ev- every instance of this class with a title and an author, and I'm going to have a method in this class that can do something. So here, create the first book with the book class. It has a title, 1984. It has an author, George Orwell. The second book has a title, The Hobbit, and it has an author, J.R.R. Tolkien. And I can things in um, display the title and the author of this particular object. And here we had a bank account example. So every bank account has an owner and a balance. Here we set the default balance to be 0. Define the owner, define the balance, and then we have a bunch of methods that make sense for this object. So a bank account, what can you do with a bank account? You can deposit, you can withdraw, you can check your balance. Deposit some amount, we will update the balance. Withdraw some amount, again, we will update the balance. And to get the balance, we will just check. And then we can use this object as many times as we want. So for account 1, for Alice, she started off with 100 euros, and deposits, withdrawals, deposits, checks her balance. Account 2, Bob started off with 10,000 euros, deposits, checks his balance, 14,500 euros. So you know, we can use this class as many times as we want. We can just reuse this over and over again. We have this object that we can reuse over and over again. For data analysis, more of what you are doing, um, you can, let's say you define a class where it will allow you to just input a model and then train the model, evaluate the model. And instead of typing in all these things, so you could even extend this to do some sort of pre-processing. So here, let me go here. I have done some, let me copy this. Let me paste it. I will paste it just right here. Well, actually, I should be logical about this. Yeah, paste it under here. So this data set that I have split into X and Y. Um, I could have done some pre-processing on it, X-train scaled, X-test scaled, and then use that scale in here. I can put this code in here. I could have it so it's model and data. Again, this is just a rough example. And then I could DEF process self X, Y, and then I could, you know, scale a scalar.fit transform, scalar, you know, and so on. But really, if I wanted to avoid doing all this sort of repeatedly, I can modify this class so that it does as much of the repetitive stuff as I can, and then all I need to do is just call my object, stick my model in there, train and evaluate, get some accuracy, define another object, stick a different model in there, train and evaluate, get some accuracy. So I can reuse a bunch of that code as many times as I want. I could have tried a third classifier, maybe a support vector classifier, support vector machine, and so on. Okay, so this is the end of today's tutorial. Hopefully you have followed along coding, but here are some exercises for you that you can use to practice. So the first exercise, write a function called my favorite stats. Basically, it takes in a list of numbers and then returns the following stats as a data frame. So it will compute the mean of the list, the median, the variance, the minimum, the maximum, and use built-in functions. So mean, max from NumPy, pandas, wherever, um, use the inbuilt functions. You don't have to compute the variance yourself. So that's exercise 1. Exercise 2, write a function Celsius to Fahrenheit that converts temperatures from Celsius to Fahrenheit. You know the formula. If I input a temperature in Celsius, I should get an output in Fahrenheit. So it would be DEF Celsius to Fahrenheit, some number, put the formula in there, return the conversion. Okay, exercise 3, create a class circle with attribute radius and then add a method area that returns the area of the circle and circumference that creates the circumference. So we will add 2 methods to our class. And then for a laptop, it will start off with attributes, brand, model, and price. So that would be self.brand, self.model, self.price. And then add 2 methods, apply a discount, some percentage, just reduce the price by a given percentage, and then display info, which will print your brand, model, and price. So just 4 exercises this week. And if you need to go over the video again and start from the beginning, feel free to do that. Okay, good luck.